Okay, so members, let me hope this is a different group from the one I met the other time, because online I have only two lectures, the one on Monday and the one today, which is now, but I teach the same thing. So if you attended the Monday lecture, maybe this one uh, is not useful to you, because I'm repeating what I taught the other time, so that different people can log in at different times at your convenience. So you either attend the Monday lecture or the Wednesday lecture. That is for my part. I don't know the timetable of other colleagues. They will be telling you. Okay. So basically, that is that. Now, first of all, good morning. Maybe I forgot to greet you. Then what I want to say is that when you want to read microeconomics, don't try to spot. You know, some people want to spot. They want to spot and say, okay, I'll not read this topic, I'll read the other one. But that way you may find problems, okay? So basically, try to read whatever you can, and discussions will help you very much. Try to discuss, go through past papers and discuss with your friends. After understanding the notes, you can start discussing, because even if you understand the notes without referring to the questions, to the past papers, you may not know how to attempt questions. But going through past papers, because we just recycle these questions, when I'm setting, I just say, okay, today let me look at the paper of 2019, and then I find a question and I bring it now. So basically, going through past papers will help you, okay? Yeah, don't worry, I'm recording the session, so you'll get the recordings and maybe the notes through your coordinators. So I'll only communicate to the coordinators. I understand you have a group, so I'll communicate to one person, and then he can give to the group of coordinators, and then they can share the notes. Okay, so basically today, we are almost just chatting about economics, no difficult thing. So we want to look, normally I start with looking at the aim of the course, so that students understand why we are doing the course. So we want to expose students to concepts and theories which are useful in understanding, explaining, and making predictions regarding the behavior of economic agent. Now, the economic agent is the individual. You know, here we are talking of economics, and the individual is the economic agent. And because this individual is the one who makes economic decisions. And when we talk of economic decisions, we are talking of things like what goods to consume, what to buy, what jobs to undertake. So the individual is the economic agent. Decisions are made by the individual. So the individual here is referred to as a decision-making agent or economic agent. So we are aware that economics is divided into micro and macro. And the universe is composed of a spectrum of problems, with microeconomics falling on one end and macroeconomics on the other. So the real world problems will always involve some admixture of the two, micro and the macro. So when we talk, of course, since we are doing microeconomics, we want to look at microeconomics so that you can understand and you can easily explain to a layman what microeconomics is. So basically, we are studying the economic actions of a particular individual or a well-defined group of individuals. When I say well-defined group of individuals, you can think of households, industries, farms, and so on. So we can look at an individual, because we start with an individual, and then we can know how the group works, okay? So here we are studying the actions of a particular individual or a group of individuals. That is the economic behavior of an individual decision-making unit. Like I told you, the individual is a decision maker. So he makes the decisions. All microeconomic decisions are made by the individuals. And the totality of these decisions define the economic environment. Now, in other terms, microeconomics may also be referred to as partial analysis, since it is the partial differentiation of the total being macro. Now, according to a certain Professor Lena, microeconomics is as if you get the economy, you put it under a microscope. You know, I hope you know what a microscope is. You put it under a microscope, and then you see how the millions of cells, of course, it is natural to, when you talk of a microscope, to also think of cells. But now, in this case, what I'm trying to say, when you put the economy or the whole world, the universe, under a microscope, now the cells would be the individuals. So you see how the millions of people behave. So in other words, he's trying to explain microeconomics in very simple terms so that you can understand microeconomics. So you put the economy under the microscope, and by doing that, you are studying microeconomics. So you see how the millions of people behave. Now we have the individuals, or you can say households, as consumers. In other words, we have the consumers on one hand, and we also have the producers on the other. So you can refer to individuals as, or firms as producers on the other hand. And these play their part in the working of the entire economy. So basically, that's why, because each individual is important and so on. So that's why we start by looking at, for instance, the demand of an individual consumer for a good, and then we go ahead and derive the group demand for a good. So that shows that the individual is important. So we start with the individual. That means we need to understand the individual. But in understanding the individual, why like he decides to undertake that job, why he decides to buy a commodity, that means we need to look at the factors that influence the decisions or the choices the individual will make. So in microeconomics, in addition to studying the individual behavior, we also have to study the factors that influence these decisions, okay? And then we want to see how these innumerable small decisions merge to determine the workings of the entire economy. Because to understand the individual, you have to understand why he has only one meal a day. So the factors leading to that decision, you need to understand them. And then another thing is that sometimes this microeconomics is referred to as price theory. In some texts, you come across that price theory. And this is because price is an important factor here. We are talking of the factors. Most people base their decisions on the prices. Like for instance, for you to decide to buy a good, you may look at the price. For you to undertake a job, you may look at the wage. In this case, the wage is the price for that job. You look at the wage. So prices are an important factor. So that's why microeconomics is also referred to as price theory. So after understanding that, now we want to look at the types of microeconomics. There is what we call the simple microstatics. So here we are looking at different microeconomic variables and their relationships at a given point in time. When you talk of a given point in time, then you are talking of equilibrium. So a given point, studying something at a given point in time, you assume that the values of the variables will not change. They will remain unchanged. Otherwise, the moment they change, you cannot look at equilibrium. So at a particular time, there is no change. Change will happen when the time changes. But now, since we are talking of a given point in time, then we are looking at conditions of equilibrium. So the variables remain unchanged. For example, here I gave the example of the demand and supply. Okay, demand and supply. We look at that equilibrium. So it gives us the equilibrium price and the quantity. So as long as these supply and demand functions remain unchanged, the price will stick to PE. So microstatics discusses the question how this equilibrium is arrived at, the equilibrium E, in the market where demand and supply are known and remain unchanged. In other words, we are saying that a simple microstatic model does not involve time period. Okay. The other type of microeconomics is the comparative microstatics. Now, of course, this one compares two different positions, equilibrium positions. How do we get the two different equilibrium positions? We assume now there is a time period, because this one, comparative microstatics, if you are going to compare one equilibrium position and another, it means that you are looking at different time periods, okay? So this one will compare the equilibrium positions at different points of time. Now, for instance, given our example of demand and supply, assuming there is a change in any of them, like a change in demand or a change in the supply or both. So this will, of course, lead to a shift in the curve. So assuming here in this example, the demand changes. When the demand changes, the demand curve shifts, okay? And a new equilibrium is reached, giving, of course, a new price. So what comparative microstatics does is to compare the two equilibrium positions. So our equilibrium position is E1 and E2. So comparative microstatics will compare those two equilibrium positions. But however, this will not tell us how we arrive at the new equilibrium position. In other words, it does not throw full light on the process through which or by which the new equilibrium has been arrived at. So it just compares the two positions. The third type of microeconomics is what we call the macrodynamics. Microdynamics throws full light on the happenings in the market during the period of transition. Remember, with the comparative microstatics, we said that we just compare the two equilibrium positions without looking at the process through which arrive at the new equilibrium position. So basically that is done by microdynamics. Microdynamics, we will explain the process through which we arrive at the new equilibrium position. It is a study of disequilibrium. Specifically, it studies the process through which the new equilibrium is established. Now, a good example here is the cobweb model. So that's why I put cobweb model here. Now, this cobweb model, of course, the name is derived from the nature. You see the diagram, the nature of the model, or the graphical nature of the model. It looks like a cobweb. That's why it is called a cobweb model. So this cobweb model is used to explain the dynamics of demand, supply, and price over long periods of time. So when we say dynamics of demand, supply, and price, you know, like as prices move up and down in cycles, the quantities produced also seem to move up and down in counter cycle manner. Now, how does this happen? Normally, we have the consumers or the demanders, and we have the producers. So basically, producers have a myopic kind of thinking. They are myopic. Like, so for instance, they always think that what they think will happen, or what they predict will happen. So for instance, they always think that the prices in the current period will also prevail in the next period. That's how they think. Despite the mistakes they make, they don't learn from their mistakes. So they continue to think that prices in this period will also be the prices will prevail in the next period. And because of that, we are going to see how we have these movements. Okay, so basically we have, like here, of course, we assume that the consumers respond to the current market prices, but the suppliers respond only to what they expect the market price to be. Like I told you, for the suppliers, they expect that the market price will be as the previous price, the price in the previous period. That's how the suppliers think. So what happens is this. So assuming we have a period 0 or a period naught here, and the price is PO. When the price is set at PO, now when you follow that through and you go to the supply curve here, you can see that that will give us the quantity which will be produced in period 1. Now, these suppliers are producing quantity Q1 because the price is high at PO in period 0. So when the prices are high, they think that, okay, let us produce more so that we benefit from the high prices. So in period 1, they base their production on the price in period 0. So the quantity will end up as Q1. But now, when the quantity is Q1, the demanders, those are the consumers. You see, what they will do at that quantity, they will set the price at P1. In other words, it means that in period 1, when the quantity produced is Q1, the prices will fall to P1. Because the more you produce, when the supply increases, automatically, okay, other things being equal, the price will fall. So that's why you see the prices in period 1 falling to P1. Now the suppliers are disappointed because they expected the price to remain here at PO, but now they find the prices down here. But they never learn from their mistakes. So what happens in period 2, they want to base their production on this price P1. So what they will do here in period 2, they will supply quantity Q2 because they feel that since the prices are very low, let's produce little so that we don't lose. They don't want to supply much when the prices are low. So they produce output Q2. Now, when they produce output Q2, which is obviously small, now the demanders will set the price at P2. In other words, say the price will increase to P2 because of the small production. So the process will continue. Now it will move like that. You see, we are moving in a cobweb fashion. I'm sure you have seen cobwebs because I know most of you don't clean your rooms. You must be having, when you go back, you look in the corner at the top there, at the top of the ceiling, you see a cobweb and it looks like that. So that's why it is called a cobweb model. So basically that we assume that because this is a convergent cobweb, so we assume that eventually prices will reach the equilibrium. So basically that is the graphical part of the cobweb. Okay, now I think it is better you concentrate on the explanation, but instead of writing nonsense in the chat. The moment you concentrate on chatting, then you will not get what I'm teaching. So basically, it is better you concentrate, okay? Of course, I cannot say anything to you because you are mature, but you know what you want when you come here. So actually, I will not say you go out of the class or whatever, but you try to optimize, okay? So basically, that means you need to concentrate if you want to pass. Okay. So now we are going to look at the mathematical bit of it. The mathematical bit. We want to derive the cobweb model. We want to derive the cobweb model. But before we derive any model, like any other model, you start with assumptions. Okay, you start with assumptions. The first assumption is that there is an immediate response of demand to changes in price. Okay, there is an immediate response of demand to changes in price. Remember, we saw in the graphical part of it, we said that the current demand will depend on the current price. Okay, so mathematically, so here we have quantity demanded at time t. Time t is the current period. Alpha is a constant, then APT, PT is the price in the current period at time t. That time t is the current period. A is the slope of the demand curve. So basically that is the first assumption, that current demand depends on the current price. The second assumption is that the supply responds to changes in price after time lag. Like I told you, suppliers will always base their decision, their supply decision, on the previous price. So that's why we say supply responds to changes in price after a time period, okay? So that's why the supply function, we have quantity supplied at time t, would depend on the price at time t minus 1. That is the previous price. So that is the second, that is the second assumption. Quantity supplied will depend on the price. B is the slope of the supply curve. We shall explain this later. So we assume that despite the supply time lag, the market will clear at any time t. In other words, quantity demanded will equal to quantity supplied. That's what we say the market will clear. The market will clear. Okay, Prosper, you unmute and ask a question. Prosper, do you want to unmute yourself and ask if you have a question? If not, you put down your hand. Okay, maybe he put up the hand by mistake. Okay, Babu, is it Baby Boo, whatever. I'm giving you some time, some chance to ask. Okay, you ask, okay?
So will you be able to send us the video after?
No, that is not a question, my friend. That is not the question I'm interested in. I'm interested in the question here. That's why you people don't concentrate. Now you are thinking of, will she send us the notes? Why don't you first listen? Okay, that is not a question. Yes, Prosper.
Doctor, I was asking, why don't we have a negative on the demand function? In the previous work that we had, there was like that thing that represents the inverse relationship. So on this demand function, I'm not seeing that negative. Why is it not there? Is this a special case?
Okay. Okay, so basically, like we are saying that, of course, we know that the negative shows that the demand curve has a negative slope. But in this case, we are just trying to, we ignore the sign, okay? We ignore the sign as a, sometimes when you're trying to derive a model, we just ignore the sign because the negative will show the slope, okay? But say in this case, we just ignore it. Okay, thank you for the question. Now, we are saying that the other assumption is that the price and quantity at any time t will not be the same as those at the ideal equilibrium. Remember, the ideal equilibrium is what we want to arrive at, the ideal equilibrium position. We are trying to arrive at the new equilibrium position, which we call the ideal equilibrium position. So the values at time t will, like for instance, the price at time t is not equal to the price at the ideal equilibrium position. We put a bar on top of the value, on top of the variable at the ideal equilibrium. So P bar means that the price at the ideal equilibrium. Likewise, Q bar means the quantity at the ideal equilibrium, whereas QT means the quantity at time t, okay? So basically, those are the assumptions. Now, so we are saying that at the, of course, at the equilibrium, any equilibrium, quantity demanded will equal to quantity supplied. So for the ideal equilibrium, remember we are just putting a bar on top of the variables to differentiate it from the equilibrium at time t. So at the ideal equilibrium, we have quantity demanded will equal to quantity supplied. From those equations we said, so this is the demand and that is the supply. But this time we don't put a t, a subscript t, because we are looking at ideal equilibrium. So that's why we are just putting a bar, and that gives us our equation 1. So this is quantity demanded equal to quantity supplied. Likewise, at equilibrium at time t is the current period, is given by that. You just bring what you had in the previous chart. So this is the demand, quantity demanded, and that is the quantity supplied. So this is the equilibrium at time t. Like we say that despite the supply time lag, the market will always clear. So we are talking of equilibrium where demand is equal to supply. So we have two equations we have created here. And from these two equations, we are going to derive the cobweb model. So we want to derive the cobweb model. But what are we trying to achieve by deriving the cobweb model? What we are trying to achieve, we want to know the price at any time between the initial equilibrium and the new equilibrium, because we are trying to analyze that process through which we arrive at the new equilibrium. So we want to look at the price, like for instance, okay, in the previous diagram where I showed you, like we want to know the price between those two positions, the price at any time between those two positions, okay? So that model, the equation, the cobweb model will give us the equation that will give us the price at any time between the two equilibrium positions. Okay, so basically that is what we are trying to do. We are trying to establish that equation. So the first thing we are going to do, we are going to subtract equation 1 from 2. We're going to subtract equation 1 from 2. So that's why, so you see, I said QT minus Q bar. Q bar was equation 1, QT was equation 2. So QT minus Q bar is equal to Now you get the whole of equation 2 here. This is our equation 2, and that is our equation 1. So you just subtract equation 1 from 2. So when you do that here, first of all, the alphas and betas will disappear. They cancel out. So you don't need to worry about those. Some people, when they see the alpha, the beta, they become worried. So now they disappear. They go out of our equation. So now what we do, we try to collect like terms together. So this side we have, of course, we have the qt minus q bar. We can put that aside, okay? But now we go to these ones. So we have APT. Now here minus AP, we go this side and we bring AP here because we are trying to collect like terms together. And then we have BPT minus 1, then minus this BP. So basically that is what it is. Remember, I've just ignored the Q's, I've put them aside. We know that these ones will equal to QT minus Q bar. Okay, so basically, this is the same. So we have this equation 3. You just put in brackets. We have our equation 3. When I pause a bit, I'm like, have they understood? Like I'm waiting for someone to ask a question. And because that will tell me that you need some explanation. But I assume if I don't see any question, because I'm looking at the chat and I'm looking at the hands to see. Prosper, ask, unmute yourself and ask.
Doctor, I wanted to please throw more light on the T. I want maybe to inquire in form of an explanation. The T, is the T like both equating to 1? Because if we say that demand is quick to respond, like when they're responding to prices, and then supply will respond later. So are we trying to say that T is the total, or T is the total time is equal to maybe 1? I'm not getting why you subtracted the T minus 1.
Okay.
Is it that like the remaining?
Okay, so basically he's asking about the T. T represents the time period. Like the current period is the T, okay? Now the T minus 1 means that the previous period. So T minus 1 just represents previous period, and T is the current period. So let me hope that answers your question. That's how we see the T's. So they don't cancel out like that, whatever I was saying. So T minus 1 is the previous period. T is the current period. Prosper, hopefully that answers the question. Now, I say someone is okay. Now let's repeat the question, the equation. Okay, let's repeat the equation. We said we have two equations. Okay, we have this equation which shows the ideal equilibrium, and we have the equation which shows the equilibrium at time t. So these equations are going to help us derive the cobweb model by subtracting this equation 1 from equation 2. Now, this is what I've done here. So you say qt minus q bar will equal to, now this is our equation 2, and that is our equation 1. Basically, that is what we have done. So like I said, the betas and alphas, these constants will cancel out. So we don't need to worry about them. They cancel out, okay? When they cancel out, okay? When they cancel out, it means that we try to collect like terms together. So we say APT, we look at this side, APT. Now we go this side and we bring AP bar because those are like terms. And then we look, remember the betas and alphas, they have gone. So that's why I'm not considering them. Now we have BPT minus 1, and then this side we have BP. Okay. So this is the same as that, like you just introduce in brackets. A into PT minus P bar, and B into PT minus 1 minus P bar. That is equation 3. Now, someone asks a question, what is the ideal equation? There is no ideal equation, but there is ideal equilibrium. I hope that is what you wanted to ask. I have not talked about an ideal equation, but I've talked about ideal equilibrium. And I said that the ideal equilibrium is the one we are moving to. Okay, so basically, I hope that answers the question. Now let's continue with our equation. So we have equation 3. Now we can make another assumption. You need to remember this assumption. Let the difference between the ideal equilibrium and the difference between the ideal equilibrium values of price and quantity be denoted by small letters. Okay, the sentence was supposed to be, let the difference between the values at the ideal equilibrium and the equilibrium at time t be denoted by small letters. Hopefully I remember to correct that sentence before I send you the notes. But I'm talking of, when you look at the brackets in equation 3 here, you see I'm talking of that difference at equation 3. The difference between the values at time t and the values at the ideal equilibrium. That difference is the one I'm talking about. So let that difference be denoted by small letters. Now people are going to ask me why, but we are saying that we are trying to make an assumption. So that means here we have a capital PT and a capital P bar. Now this whole difference will be represented by a small pt. So when you see a small pt, like here I say the pt minus p bar is equal to a small pt. Likewise, qt minus q bar is equal to a small qt. Remember here we have a qt and q bar. So that is represented by small qt. So using these equations, now that means our equation 3 becomes Q2, remember that small qt is equal to APT, which is equal to BPT. Now these are small pts as per our assumption. In other words, here the Q is not important because, like I told you, when we are driving the Cobwe model, we are interested in the price. So that's why the QT is not important. Actually, we ignore it. So we deal with these two. APT will equal to BPT minus 1. So that means we said that in our equation, we are trying to derive the price at any time. Okay, the price at any time t. So what we do here, we make PT the subject. When we make PT the subject, we derive the Cobweb model. So equation 6 shows the Cobweb model. It shows the time path the price will follow towards the ideal equilibrium. So A is the slope of the demand curve and B is the slope of the supply curve. These slopes will determine the nature of the cobweb, as we are going to see. So basically, if A is greater than B, in other words, if the slope of the demand curve is greater than the slope of the supply curve, then we have a divergent or explosive cobweb. Okay. In other words, what I'm trying to say when I say the slope of the demand curve is greater. Now, when you look at this, it means that the demand curve is steeper than the supply curve. So in this first diagram, where I say divergent or explosive cobweb, you see the demand curve is steeper. Now, and the supply curve is more elastic. So when you start, like we said here, with the price here, so if you have such, you see you are having a divergent cobweb because you are moving further and further away from the ideal equilibrium, from the equilibrium. So that's why we call it a divergent or explosive cobweb. We are moving away. So that means the ideal equilibrium is never attainable. Okay, it is never attainable. So we call this unstable equilibrium in terms of equilibrium analysis. Okay, so then okay, now let me go back a bit. Someone is saying that if we are making PT the subject on the equation, why do we still have PT on both sides of the equation? So when you look at the cobweb model, you don't have PT on both sides. This is PT minus 1. It is not PT. Remember, PT minus 1 is the T in the previous, the price at the previous period. So this PT is the price in the current period. So we don't have we don't have what? We don't have PT on both sides, okay? Now, if A is less than B, then we have a convergent cobweb. The convergent cobweb is like here. So the slope of the supply curve is greater than that of the demand curve. It will come automatically when you try to do that. When the slope of the supply curve is greater, you can see we are moving towards the ideal equilibrium. So prices are converging and eventually the ideal equilibrium is attainable, and we refer to that as stable equilibrium. And if the two are equal, then we have a regular cobweb like this one. So prices will move around the equilibrium without ever reaching there. So when the two slopes are equal, you get such a cobweb, and we call that neutral equilibrium. Now, that is the cobweb. You can read about the limitations of the cobweb model. Okay, the limitations of the cobweb model. Now, the cobweb model, someone is asking the importance of the cobweb model, but see, we started from the beginning saying that we are looking at microdynamics. It helps us to analyze the what will happen, to know what will happen. Like for instance, you know that when the price is set at a certain price, then you know what may happen and the decisions of the suppliers and so on. So basically, we want to see how the individuals will behave and so on. Still, it tries to explain a part of microeconomics, which is the microdynamics. We want to look at the dynamics of prices and the quantities produced. So that is the importance of the cobweb model. So eventually, you know how prices will move and so on. So of course, you look at the limitations of the cobweb model, which limitations are derived from the assumptions. You go to the assumptions, like for instance, we said that producers already think that their plans will be fulfilled, which is not always the case. When I say their plans will be fulfilled, they already think that the prices in the previous period will also prevail in the current period. And so they want to base their production on those prices, and then eventually the things don't go as they plan. Okay. Now, of course, now this critique the assumptions. You can go through that yourselves and try to discuss, and you can think of how to discuss the assumptions. So basically, that gives us the various types of microeconomics. Eventually, as we go further, you see that whatever we're going to study will fall within any of these three: the simple microstatics, the comparative microstatics, and the microdynamics. Harriet, unmute yourself and ask a question.
My question is, does the Cobra model apply to all commodities or specific commodities?
Okay. Prosper, ask. Prosper.
Madam, I don't know whether I wanted to ask about the small p's. Aren't we supposed to have maybe a third p, like that is representing the one that has b into t minus 1, then p constant for the third equation? Because when you come to this other side, you put b pt minus 1. So don't we assume another small pt minus 1?
That's what we did. Let me take you back, but that's what we did. Let me take you back to that slide. Okay, let me. I think Prosper is asking about, let me see here. So we said that the differences here are represented by small p's. That's why here, pt minus p bar is represented by a small pt. So that means this pt minus 1 minus p bar will also be represented by a small pt minus 1. Okay, so it is a pt minus 1. That's why when we go to the next whatever, you see here, I have a bpt minus 1. So this p is a small pt. So I hope that answers Prosper's question. So here we are looking at small p's. So if it is a pt minus 1, so it is a small p, and so on. Now I've forgotten the other question. Harriet, can Harriet ask maybe in the chat? I've forgotten what she has asked. Can someone remind me what Harriet asked? Harriet, can you ask me what, maybe in the chat? Oh, okay, thank you. Okay. Does it apply to all commodities? No, it cannot. All these theories cannot apply to all commodities, because in economics, there is what we call other things being equal. Other things being equal, okay? So basically, actually, I was going to discuss this below here. Here, the nature and role of theory. So whatever we are doing here, we cannot say it applies everywhere, but at least it is a basis. It is maybe something we can base on, but does not really apply everywhere, because there is this phrase, other things being equal. This indicates the limitations within which many, if not all, economic laws operate. So economic laws or theories, they operate within some limitation or some kind of boundary. So we cannot say it applies everywhere and whatever. So when we talk of, because we are looking at microeconomic theory, we briefly want to go through the role of theory and the nature of theory, what theory is, so that you can you can understand. So a theory is a hypothesis that has been successfully tested. So this has been successfully tested. Now, you see the cowboy model, but see, people, that means when you move around, you don't observe things. You go to these agricultural products. Actually, the cowboy model works well and whatever. Now, this season, you plant a lot of tomatoes. No, okay, tomatoes are scarce. And you think, okay, let me produce a lot of tomatoes so that I benefit from the tomatoes. Then when the period comes, everyone has done the same, and there is too much supply. And then the price of tomatoes fall because there is too much in the market and whatever. So basically, that is how we use the cowboy model. So if you are an economist, you can use the cowboy model to tell you that don't be like that. I mean, like, you know that if you plant, everyone will be planting, and eventually there will be a lot of tomatoes in the market, and then you'll get little from it. So that's how the cowboy model works. So as an economist, you expect to use the theory now in your day-to-day activities, okay? So you go slow, you say, okay, there is a high demand on tomatoes, little is in the market, but everyone is thinking like that. So they will go and plant. You also plant, and maybe if previously you planted an acre, you want to plant 2 acres and whatever. And then to your disappointment, by the time you harvest, everyone has harvested, the prices have fallen, and you don't benefit from your tomatoes. But then, because you don't learn from your mistakes, what you do the next season, you go and plant very little, because the tomatoes now, the prices are low. Then when you do that, everyone is doing that, and then you get disappointed again in the next period. So basically, that's how the cowboy model works, okay? Hope everyone now understands that. Okay, so basically, when we talk of a theory, normally when I say theory, think of a simple theory like the demand theory, the law of demand. Because when I think of theory, it is like a law of demand. So you think at that, when you come up with a theory, the moment you have a theory, then you do what? Then you know that it has been successfully tested. Okay, it has been successfully tested. When you test it, then it becomes, the hypothesis has been tested, then it becomes a theory. How do we test? Like, for instance, you go maybe to a butcher shop, you sit there the whole day and realize that maybe when the price, or maybe several weeks, and you realize that when the price increases, people buy less meat. And then you come up with a hypothesis that the higher the price, the lower the quantity bought. But then at that point, it is a hypothesis because you are only observing it at the butcher shop. You don't know whether it is also happening for other commodities. So what you have to do, you have to test that hypothesis. So maybe this time you opt for a supermarket where we have a variety of commodities. And then when you do it, you make the observations for several months and whatever, and you realize that when the price increases for any commodity, then people will buy less, then you have successfully tested the hypothesis. So this theory expresses a causal relationship between sets of phenomena. One is a cause, the other is the effect. But like we are saying that economic theory or laws represent certain economic tendencies, expressing what is likely to happen, or other things being equal. The purpose of theory is to predict and explain. So a theory's usefulness depends upon how well we can predict from it and how important the hypotheses are to us. Of course, if the hypothesis is not important to us, then we don't even need it. So basically, we can consider that. Characteristics of economic theories, you can read this on your own. Like theory is a generalization, of course, because of this phrase, other things being equal. It is, we can say generally, when the price increases, the demand falls. So that is a general clause. So economic theories are generalizations because their conclusions are subject to exceptions and are often tolerably accurate. Theory as abstraction. Theories are necessarily abstractions. So a theory is useful because it tries to eliminate some secondary features of reality so as to highlight the essential characteristics. Like you cannot look at each and everything in the economy or in the world. You have to look at some important features. That's like you consider, you can have an example of a map. A map is an abstraction. Okay, so basically, likewise, theory is like that. Theory is amenable to mathematical and graphical techniques. That's why you see sometimes we use mathematical, sometimes the graphs and so on. And also, so basically, that is the characteristics of economic theories. Now, application and uses of economic theories, of course, to provide tools for economic analysis, where economic problems, normally they are tools, economic tools used by economists, which analyze the economic problems, interpretation of economic phenomena of the real world. So by using theories, we can interpret the phenomenon of the world. And these theories can also suggest solutions to the prevailing problems in various countries. But we can also look at, it can help us predict and observe the economic events. Like for instance, sorry, with my voice. For instance, how do we use theory to predict and observe the economic events? Now we know that the theory of demand or supply, when the supply increases, prices fall. Isn't it so? So that is the theory of the law of supply. Supply increases, price falls. Now, what if we look at sugar and then we realize that the supply of sugar has increased? So as an economist, I would know, obviously, from the law of demand or the law of supply, that the price of sugar is going to fall. But then what happens that after a week, now, like for instance, we can use an example of fuel. So at one point, the trucks were held up at the border, and then the fuel prices went up. And then eventually the trucks were released, and everyone expected that the prices are going to fall. But then what we are observing is that the price of fuel is not falling. Now, what can this tell us? Because we want to use we are using the theory to predict something which is not observed. Now, right now, we cannot observe the phenomenon. Okay, because for us, what we know is that because of the law of supply, the price of fuel should be down now to its original point, but the fuel is not falling down. Actually, it is increasing because at one time the fuel was at 5,000. Now I see it at 5,080. I don't know what will happen next week. So as an economist, that should tell you something. Okay. It should tell you that actually there is going to be a shortage. That's why prices are not falling. There's a problem somewhere. Policies are formed from theory. We can judge the performance of the economy from theory. Like when you want to look at the different sectors of the economy, how they are performing, we base all these on theory. Now, in your free time, you can read about positive analysis and normative of value judgment, because that's what you did in your first year, but we just want to revise that. So of course the notes are there, but I'll not go through that, okay? You can read about that. And that is the end of the first slide, not lecture. We are continuing, okay? Any question before I go to another slide, another set of slides? So basically that is the first part. Now I want to go into something else. Okay. Okay. So basically, before we continue, the course outline, the coordinators. You people, do you contact? Are you in contact with your coordinators? So I would give everything to the coordinator or my colleague, okay? And one thing I don't want to see again in your charts is about the notes and the slides. That one I don't want to see, because I've told you I'll give you the slides through your coordinators, and I'm recording the session and I can give you the recorded session, okay? So you'll have everything. So don't waste time, just concentrate on the lecture, okay? So basically your coordinators will have everything, but because I cannot email everyone, okay? I'll email this like, like by Monday, you'll have the recorded lecture, okay? And the course outline, I'll give the coordinator. Okay, let's look at the theory of consumer behavior. Remember, we are talking of, now in the beginning, we talked of the individuals as consumers and individuals as producers. So now we are starting with the consumers. So we want to look at the consumer behavior, the theory of consumer behavior. So we want to examine consumer behavior. Oh. Okay. Of course, we want to know why individuals choose what they choose. So we start by examining consumer behavior in the consumption decisions, okay? So for instance, a consumer desires a commodity, of course, because it gives him more utility than others. Of course, you've come across the word utility. Utility is that satisfaction you get when you consume a commodity. It is the power to satisfy a want. Okay. Obviously, a commodity which gives you more satisfaction is more desired. Okay. So that means commodities possess a common characteristic which we call utility. But when we talk of utility, it is simply whatever makes the commodity desired. So that means utility does not mean usefulness. It means desireness. Okay. Like for instance, we have some commodities which are not useful to us, which are even are harmful to us. But because we desire them, then they possess utility. Like some people enjoy drugs like cocaine and whatever, and even alcohol. However much they tell them that they are harmful, they are dangerous and whatever, people enjoy them. So they possess utility. So utility does not mean usefulness. It means desiredness. Now, this theory of consumer behavior is used to analyze consumer behavior during the process of utility maximization. The aim of the consumer is to maximize utility. That's why we say we are trying to analyze his behavior during that process of maximizing utility, because that is his aim. Now, of course, for you to maximize utility, to maximize satisfaction, it means that there are some assumptions still here. Like for instance, you need to have full knowledge of all the commodities available and their prices. And also you have to be aware of your income. Some people don't know their income. So they will go to buy expensive things when their income is little. Anyway, as long as you know your income, that will make you maximize. Now, for instance, assuming I go to a shop to buy a dress, and then I go to the shop, they tell me the price, they show me the dress, and I'm happy with it. So I pay for it. Then I move out of the shop when I'm very happy. Then 3 shops from that one, I see the same dress at a lower price. Would I still be happy? Now, what is causing that is that I didn't have full knowledge of the available commodities and their prices. If I knew that 3 shops ahead, there is a cheaper dress, obviously I would go for that, probably, if it is the same dress. That's why I say here, if the consumer wants to maximize utility, the assumption is that he has to have full knowledge of the available commodities, their prices, and his income. And then he must be able to compare the satisfaction or the utility of the various goods which he can buy with his income. In other words, you can be able to evaluate the alternatives. So we assume that you have a calculating mind where you can say, okay, this commodity gives me so much utility, this one or whatever, even if you cannot say, maybe count, but at least you know that this one is better than the other one and so on. So we assume that. Though this assumption is a little bit difficult to assume of a consumer, because no one, like it is assuming that the consumer is putting a lot of commodities in his head and he can compare all of them and so on. So basically we have a problem here. And the problem is comparison of utilities. That is a problem. And how did the economists solve that problem? So there are 2 approaches. There are 2 approaches to the comparisons of utilities. Like they are trying to help the individual to be able to compare utilities. We have the cardinalist approach and ordinalist approach. Of course, you have come across this in your first year. By the way, with the economics, even the first year work is important, because this is what we are doing now, actually, right now. This is just expanding on it, so you don't need to forget totally about it. So basically, we know these names are borrowed from mathematics: cardinal numbers, ordinal numbers. So we have the cardinalist approach, or the cardinalist school, which postulates that utility can be measured in monetary units. And then the ordinalist school, which postulates that utility is not measurable, but rather it is an ordinal magnitude. In other words, the individual can rank commodities according to satisfaction. So we start with the cardinal utility approach. We have the assumptions, which you all know. The consumer has a fixed budget. In other words, we assume that the income does not change, it is fixed. The consumer is faced with a number of commodities whose prices are fixed and known. From that assumption of he has full knowledge of the prices. So we assume that the prices are known and fixed. In others, in the analysis, we don't assume prices to change in this analysis here. Not always, but I mean here, the assumption. The consumer derives satisfaction from the consumption of every commodity consumed by him and not by others. In other words, you have to be the one consuming the commodity in order to derive satisfaction. It is not a situation where because your father is driving a Benz, so you go about boasting about my father drives a Benz, my father. You are not the one driving the Benz, so it is not yours. You cannot derive satisfaction from that. You have to be the one consuming the commodity. Then the consumer can measure numerically the exact satisfaction derived from the consumption of a good. So like, for instance, when you bite an apple, whenever you bite, you can know, okay, these are 2 units or 2 utils or whatever. So like you can measure numerically. That is the assumption. The law of diminishing magnitude is assumed to hold. Sometimes that's why I miss the physical classes, because with the physical classes, you will be the one giving me these explanations here. Like for instance, the marginal utility and the diminishing marginal utility. These are the one you've done. Yeah? These are the one you've done. So you should be knowing. Okay, by marginal utility, we are talking of the additional utility. Okay, we are talking of marginal utility is the additional utility you derive from consuming extra units of a commodity. Okay, now when we say it is diminishing, it means that this additional satisfaction you get is reducing. Like for instance, if I buy the first unit, or if I consume the first unit, I get a higher marginal utility, a higher extra unit. But then as I consume, the total utility increases, but the marginal utility reduces. Now here. So you can see here, we have the total utility curve and we have the marginal utility curve. Now, when for the first units here, they are like unit 1, unit 2, unit 3. As you consume more, the total utility increases. Total satisfaction increases. But then the marginal utility here reduces. Like for the first unit, you have marginal utility 1 for the first unit. When you consume the second utility, the second commodity, the second unit, then the total utility increases, but the additional utility you derive from it is lowered. Okay, so that's why when you have just started consuming a commodity, you feel more satisfaction than when you have like when you have a lot of it, you don't feel more satisfaction. So marginal utility is the additional utility derived from successive units of a commodity. Let's look at it mathematically. We have the total utility. Here, we assume that utility is a function of 2 commodities, X and Y. Of course, we assume 2 commodities for simplicity, but remember in the assumptions, we said that the consumer is faced with a variety of commodities. But now let's assume that the individual is faced with 2 commodities, X and Y. So his utility function is given by that mathematically. Okay, now how do we get the marginal utility from that? Marginal utility is given by the first order partial derivatives. In other words, you differentiate the total utility with respect to X and Y to get the marginal utility. So these values here show the marginal utility of X and marginal utility of Y. Okay, so basically that is the marginal utility mathematically. Now we want to show the diminishing marginal utility. So we want to see that we want to show that the marginal utility is diminishing. So first of all, we derived the marginal utilities here. It is du dx and du dy. That is the marginal utility. Now we want to show that these ones are falling, they are diminishing. So what we do, we get the partial derivatives of the marginal utility of x and y. Remember, to get the marginal utilities, we got the first order partial derivatives of the total, that is of the total utility. But now we are differentiating the marginal utilities of x and y. So that gives us the mux dx. You differentiate the marginal utility of x with respect to x, which shows that we want to look at the change in the marginal utility of x when we change the quantity of x. And this one, the change in the marginal utility of y, d is the change. The change in the marginal utility of y when we change the quantity of y. So basically that is what it means, okay? So, or in other words, we are trying to talk of the second order derivatives of the utility function. And these are written as that. So this equation here is the same as this one. I just wanted to put it in simple terms so that you understand what this means. So the squared u dx2 is the same as the marginal utility of x over dx. So basically that is the derivatives, okay? But now these ones are negative. And because they are negative, it means that the marginal utility will decrease as consumption rises. So because we know that when you consume more, you get less utility. So these ones are negative, the marginal utility. We shall revisit that when we come to ordinal utility approach to show why they are negative. Now we want to look at the equilibrium of the consumer. First of all, let's assume he's faced with only one commodity X for simplicity, so that we understand this. So utility is a function of X here. And the budget is the price of X times the quantity of X. That is his budget, because he is faced with only one commodity, X. So price of X, we assume that he consumes, he exhausts all his income. So that's why we say budget is equal to PX, X. So the consumer's objective is to maximize utility subject to the budget constraint. Why are we calling the budget a constraint? Because in the assumptions, we said that the budget is fixed. So we cannot do anything about the budget, it is fixed. So whatever we do, we have to work with the budget we have. So it becomes our constraint to the maximization of utility. So the whatever we do is subject to that constraint, which is the budget. In other words, we are trying to maximize the difference between his utility function and his budget. Mathematically, we write it like that. We come up with this function. We want to maximize max is maximize. We want to maximize the difference between the utility function and the budget constraint. So that is that we come up with that function. Now, what we do, we want to maximize that. And the mathematicians tell us that maximization is achieved when the partial derivatives are set to 0. Now, those are the mathematicians. You go and ask them, don't ask me. But they tell us if you want to maximize a function, you set the partial derivatives to 0. So now we come up, we go to the partial derivatives. We say du dx, remember du dx, we here. Now the partial derivatives, the derivative of u with respect to x, because now we are dealing with only one commodity x. So we say du dx. Then we differentiate that budget pxx with respect to x. So we say the pxx over the x. And then we equate it to 0. So du dx is the magnitude of x. And now when we differentiate this with respect to x, we get px. Okay. I don't know, I saw someone putting up the hand, but maybe he has changed his mind. So when you differentiate this, now here we need to pause a bit, because when I say the pxx over the x is equal to px, what people may think is that I'm just canceling out the x, and then I remain with px. Well, this time it works, but not always, okay? We don't just cancel out. We need to differentiate that, okay? Like I can just give a small example. Now, when we differentiate pxx, normally what we do, we look at the powers of the variables. So the power of the variable with which we are differentiating with. So we are differentiating with respect to x. So we look at the power of x. So in this example here, x is to the power 1. So what we do, we just write, we look at the power. So you multiply it into the function. So you say 1 into px x, then minus, then px, that is price of x, then you subtract 1 from the power. You subtract 1 from the power. Oh, sorry. So when you subtract 1 from the power, I'm trying to do this, but you see, sometimes I'm trying to move this chart. Okay, let me close it. So what I'm trying to do here is to put you say 1 minus 1. So you multiply the power of the variable we are differentiating with, okay, into the whole function. I hope you've seen what I've written. Then this is px, this one px, then times x, then you subtract 1 from that power. So when you subtract 1 from that power, you have pxx, you have pxx to the power 0. Now that's what you have. And we know that any number to the power 0 is equal to 1. So that means now the x to the power 0 will go and we will remain with px. So that's how we get this px. So that is the differentiation. Now, when you take this to this side, you have magnitude of x is equal to px. And that is the equilibrium of the consumer. The consumer is in equilibrium when he equates the magnitude of a commodity to its price. That is when he will be in equilibrium. And actually, from this, we come up with what we call the water diamond paradox. The water diamond paradox. Yes, Prosper.
Doctor, sorry to take you back.
It's okay.
The time when you are finding the second derivative, is the second derivative of the marginal utility, is it representing the lower area? Is that part of the negatives? And I never understood what we're trying to represent there. Are we trying to show that the marginal utility is just negative, like it's now moving into a negative position, in a negative side?
Okay, for which part? For the diagram?
No, for the second derivative, when you are
Okay,
differentiating the
like,
marginal utility.
okay. I said that, okay, let me see. I said that actually, let me go back to that slide. I hope this is the one he's talking about. The second order derivatives, they are like this, but they are negative. And I said that I'm going to show you that later when we are dealing with ordinary utility approach. But you know that you should just, for now, you can just cram it that they are negative. But I'll show you. We shall derive that, and you see that actually the derivatives, the second order derivatives are negative, okay? I hope that answers his question. Prosper, does that answer the question?
Maybe we shall see. Let's maybe continue. I shall get it from there.
Okay. So when I say we shall derive and show that it is negative, you understand, okay? Because it is a fact
Yes.
that they are negative. But
Yes.
now maybe later on what we are going to do is to show that they are negative, okay? Okay, let's continue. I was saying that the individual is in equilibrium when he equates the marginal utility and the price. In other words, he's willing to pay a price which is equal to the additional utility he derives from the commodity. And from that, we have what we call the water diamond paradox. Why is it a paradox? It is a paradox because we are wondering, why is it that water, which has great value in use, has little value in exchange? In other words, water has a low price. You pay very little for water. Yet diamonds, which are of little practical use, have a great value in exchange. Like the price for diamonds is high, yet it has little value. So this is explained by that marginal utility, equating the individual equates the marginal utility to the price. So because the marginal, water is in plenty, and so the total utility is high, the marginal utility is low. The more you consume, the lower the marginal utility. And since the individual is equating the marginal utility to the price, that obviously means that since water gives him a low marginal utility, then he was willing to pay a very low price. Yet diamonds, because he consumes, he doesn't come across these diamonds. The moment you have one piece of diamond, you'll be like, the marginal utility is very high. So you are willing to pay a higher price for that. That is the explanation for the water diamond paradox. Someone would wonder, but where did this come from? So this, we have what we call the economic theory of value. And this concerns the determinants of the value of a commodity. So what is value? Because we are talking of has a great value in exchange, has a great value, whatever, okay? What is value? And the meaning has been changing over time, okay? Value, first of all, was thought of as being in some sense synonymous with importance, essentially. So basically, when we say something is important, so like it has value, okay? But then we are saying the definition, the meaning has been changing over time. Today we regard value as being synonymous with price, not importance. So something costly, we assume that it has a high value because it is expensive and so on. Now, according to this Thomas Aquinas, he believed value to be divinely determined. That means Allah determined the something which is the value of the whatever. But see, humans are the one who set the prices. So God determined that water is valuable. Then humans set the prices. So it was possible for the price to differ from its value. Okay, now we are looking at the evolution of the meaning of value. According to Adam Smith and David Ricardo, value of a commodity means value in use, whereas price represented is its value in exchange. So we have value in use and value in exchange. So water has a high value in use, but it has a low value in exchange. So the distinction between these two concepts were illustrated by the water dam and the paradox. So several economists propose that it is not the total usefulness of a good, but rather the usefulness of the last unit consumed. That usefulness of the last unit consumed, they are talking of the marginal utility. So the paradox was resolved by Alfred Marshall, who showed that demand and supply simultaneously operate to determine price. So basically, that was just to divert a little to show why we say what happens, why water carries a small value in exchange than diamonds. Okay, of course, I know we are soon finishing. I know maybe you are tired, but bear with me for some 10 minutes, okay? And we finish this. We want to finish the cardinal utility approach. At least next time we start with the ordinal. Remember, in the other derivation, we assumed that there is only one commodity X, but in the assumption, we are dealing with a variety of commodities. But still, for simplicity, we shall look at only two commodities, X and the Y. So we want to see how we derive the equilibrium of the consumer when we consider two commodities. So this time utility is a function of X and Y, and that means the budget now becomes PXX plus PYY. Now that is the budget. So of course, the consumer's objective is to maximize utility subject to the budget constraint because the budget is fixed. So it is a constraint. Now here, we form what we call the augmented function, objective function. How do we form it? We add the utility function, this utility function here, to the budget constraint. So that's what we call the augmented objective function. So we added the two. We call that function Z. You can call it whatever you want. I'm calling it Z. Okay? So Z is that function we have formed. So you add the utility to the budget constraint. But then we need to introduce in another variable. Now, these are the mathematicians telling us that this problem of maximization is achieved using what we call the Lagrangian multiplier. So that's why we introduce in that variable. And let me call it lambda, but it is the Lagrangian multiplier. You can represent it by any sign you want, but I'm using this lambda. So it is the Lagrangian multiplier. So when you form a composite function, you multiply that multiplier by the budget. So that is how we start. Now, utility is at maximum when all the partial derivatives of Z with respect to the three variables are set to 0. Remember, even in the previous one, we said that utility maximization is achieved when the partial derivatives are set to 0. But now this time we have three variables, and we shall look at X and Y only. Lambda will come in another part. In this section, we are interested in X and Y. So the Z, the X, when we go back to here, this function here, so you are differentiating with respect to X. So you say dz dx. Then you come here, say du dx. And then you also differentiate all this with respect to X. So we have du dx minus lambda px. When you go back here, of course, pyy will be a 0 because there's no X in pyy. It will be a 0. Then here, when you differentiate like we did in the other equation, you remain with px, the X cancels, you remain with px. Then you bring in this lambda because we are multiplying every variable with lambda. So that's why here we remain with lambda px, and then we equate to 0. Then we do the same for y, and we get equation 3. So from these two equations, du dx is equal to lambda px, du dy is equal to lambda py. Du dx is the marginal utility of x, and du dy is the marginal utility of y. So we have this equation. Magnitude of x is equal to lambda px. Magnitude of y is equal to lambda py. So that means lambda will be equal to magnitude of x over px, which is equal to magnitude of y over py. So this is the equilibrium. What does that mean? It means that, say, the individual is in equilibrium when he derives the last shilling, he derives the same utility from the last shilling spent on commodity X and that spent on commodity Y. So it means that you derive from each shilling spent on X and on each shilling spent on Y. So you are in equilibrium when the magnitude derived from each shilling spent on each and every commodity is the same. So that is the equilibrium of the consumer. So what do you think will happen if instead we have the magnitude of X being greater? Like for instance, if I change this to put greater, if we have this, obviously it means that he's deriving more magnitude from commodity X because the last shilling spent on commodity X, the magnitude derives from the shilling spent on commodity X is greater. So that means he prefers commodity X, but in this case, he's not in equilibrium, okay? He's not in equilibrium. So basically, what he has to do here is, what he has to do if the magnitude of px, magnitude of x over px is greater than that of y, what he has to do, he has to increase the consumption of commodity x. Of course, when he increases the consumption of x, it means the magnitude of x is falling. And when it falls, then eventually it will equal to that of y. So basically, that is that. Any question? I think I'm also tired. I know you are also tired. Any question? Is that clear? I think this is enough for today. If you don't have any question, then, okay, Tinker, unmute yourself.
Okay, madam, it's not a question, it's just a suggestion. Okay, like you were suggesting that if it were physical, it would be more like interactive, like would be interacting. It is also possible.
Don't
here,
worry,
like
the physicals are coming. We shall go through some of these things when we meet physically.
Okay, madam, thank you.
Until you coming back on 5th. When are you coming
Yes,
back for physicals?
I think 5th next month.
Yeah, we shall go through that, but still we need to teach now.
Okay.
Otherwise,
Okay,
you'll be complaining that we are not receiving lectures. What about Kazungu Enoch? Oh, Kazungu. Sorry, okay, MJ. MJ, do you have a question?
Madam, I'm requesting, would you share for us the network wasn't good by then? I'm asking for it.
I'm not hearing.
I'm saying, like, the recordings should be shared because
No, that
the
is not a
network wasn't
question
fine.
I'm expecting. That is not a question. Alan, do you have a question?
Madam.
Yes?
Are the notes there already?
Sorry?
Are the notes there already, like printed notes?
No, that is not a question. I'm asking for questions about the lecture, not those. Okay, now let me say this maybe one more time. I told you
Madam.
that After I've recorded this one, actually, let me stop recording because I don't need, let me stop the recording.